Good day. So I'm going to show you how to how to find the frictional force whenever the applied force is inclined. So whenever the applied force is inclined, when we use this formula, Fk is equals to mu Kn, be aware that the normal force is not equals to Fg in this case. You might be surprised. I'm going to explain why. So just before I continue, don't forget to like the video and subscribe to my channel so that you can receive more things like this. And if you want me to create a certain video, just comment on the section below and I will respond. So why is the normal force not equals to the gravitational force? It's because if we draw the free body diagram of this stuff, let's draw it. So of course we will have normal force, and of course we assume that is equals to Fg, but I'm going to show you something. So this is the applied force, so we just copy and paste. So since it's facing diagonal like that, we have to put it the same. So if the block moves to the right, the frictional force will be to the left. So here's a problem. The problem is whenever a force is not horizontal or vertical, we have to resolve it to its component. So in other words, here we've got Fa cos theta, and there we've got Fa sine theta. So there is the horizontal and vertical component of this. So if I redraw this stuff, we've got the normal force, and then at the same time we've got the horizontal component, Fa sine theta, while it's this side we've got the vertical component. I mean, this side we've got the horizontal component, and then there we've got the gravitational force. This side we've got Fk. So why is the normal force in this case not equals to the gravitational force? The reason why the normal force is not equals to the gravitational force is if the normal force were to be equals to the gravitational force, then we've got an extra force pushing upwards, meaning that this block cannot be balanced anymore. It will have to move upwards. But the fact that it's balanced, the fact that it's not going up or downwards, it means that the total upward forces cancels with the total downward forces. So in other words, this cancels with both this. So meaning this is not equal to this. It means what it means is these two forces both work together in order to be equal to the gravitational force. So I want you to be aware whenever we've got this situation where it's inclined, there is a vertical component working together with Fn. So it means that the combination of these two forces will be equals to the gravitational force. So it means Fn plus Fa sine theta will be equals to Fg. You see, so in this case, Fn is not equal to Fg. So what do we do here? Let's calculate for the normal force. So we know our Fa, according to this, was 200 newtons. So we're going to say 200 sine, the angle that I put there was 30 degrees. So sine 30 equals to Fg. Fg is mass times acceleration due to gravity, so it's 100 times 9.8. So that we have our Fn. So the answer of this, let me continue on top. So we're gonna have Fn is equals to 200 times sine 30 is not equals to Fn plus, I'm just copying this, but in place of this I'm putting the answer. So that's gonna be 100. And then this side, 100 times 9.8, that should be 980. Okay, so I manually set this thing. So because I set it manually, we're going to have a negative answer, but that does not usually happen. So if we're not going to have a negative answer. I actually thought we were going to have it. So this is actually going to be 880. I actually manually set this. I didn't copy it from anywhere. All right, so that's our Fn. Now we can find our frictional force. So Fk equals to mu Kn, right? So Fk is equals to our coefficient of friction, which is 0.1, times our normal force, which is 880. And anything times 0.1 is the same as dividing by 10. So this is the answer. But of course, you can use the calculator. So always remember, whenever this is inclined, the normal force is not equal to the gravitational force. There's two forces that combine to be equals to 1 so that they can still be balanced. You see, if this was equals to this, let's just say this was 10 and this was 10, right? and this an extra force, maybe 20, then it means the net force is 20, because these two will cancel and the net force is 20 upwards, meaning that this thing is not supposed to be stationary but going upwards. But the fact that it's stationary shows that this is not the case. It shows that these two work together to be equal to this. So maybe this can be 30. So that here we've got 10 plus 20 equals to 30. So these two balance to be equal to that. So here is a dangerous situation where we have got a force applied kind of downwards. So what do we do here? So let's draw the free body diagram. So of course we'll have our normal force and we've got gravitational force. So a lot of students miss it in by doing this. Maybe they will draw this like that, right? But when you draw a free body diagram, you always draw it as moving away, not towards. For instance, let's just say we've got a block and we've got a person pushing this block to the right. So with a force of 500 newtons. So we will not draw it like that when we draw the free body diagram. We always draw it as moving away from the object. So we copy the same direction. We just copy and paste the same direction, but we will not put it before, we'll put it after so that it can be pointing away. So instead of drawing an arrow pointing towards it, what you would do is to point it away, right? We just copied and pasted the direction. If we check, they're parallel. It's just the same direction, but we don't make it moving towards. Yes, in the diagram it's moving towards the object, but in the free body diagram it's moving away. That's the rule of the free body diagram. So we will have, okay, fine, we'll have the applied force there. Okay, so we have it there. So we're going to have FA. And then if the block moves to the right, of course, our frictional force will be that side. So here's the thing you should do with it. So of course, this is not horizontal or vertical, right? It's neither horizontal or vertical. So we have to split it into its components. So if we split it, this will therefore be F applied cos theta. In some schools, actually, some teachers will actually prevent you from drawing the force that is diagonal. They would rather prefer you drawing the components only. That's how it is in some schools. So this is FA sine theta. So of course this was FG. So if you look at this situation, you see before it was the normal force working together with the vertical component to be equal to this. But in this case, it is the FG working together with FA sine theta to be equal to Fn. So you must always draw the free body diagram whenever we have this situation. So if they ask you to find the frictional force and you're given coefficient of friction, but yet the F applied is diagonal and not horizontal or vertical, you always have to draw the free body diagram so that the forces are clear to you, so that you can know which two forces are working together. So in this case, the normal force is equals to the combination, right? This is equals to the combination of these two, equals to Fg plus Fa sine theta. So the normal force is equals to our Fg, which is 100 times 9.8. And our force applied is 200. So 200 times sine 30. 200 times sine 30 is 100, and this gives you 980. So if you add both these together, the answer will just be 1080. That's our normal force. Then we can easily find the frictional force. So Fk is equals to mu Kn. So it's equals to coefficient of friction, which is that, times the normal force which we got before is 1080. So the answer will just be 108 newtons. And there we have it. So remember these two situations. Okay, so I decided to do one more, and I don't have a calculator close by, so I'm not going to go to the full detail of the answer. So let's say we have this situation and the coefficient of friction is 0.1, and we want to find the frictional force. So when we draw the free body diagram, we're going to have the normal force, we're going to have Fg perpendicular, then we're going to have Fg parallel. And if the block moves up the incline, we will have Fk. If it moves down the incline, then Fk would have been that way. Now, when we draw this, of course, we're going to have, so we just copy and paste the direction. So let's just say force applied is probably 500. Let's make it 500 newtons. So 500 newtons. So here's the thing. So this is 10 degrees, of course, but now we have to split this into its component. We have to split it into the horizontal component, which is FA. So I wrote the number just, but let me just write it in symbols. So horizontal component FA cos theta, vertical component, let's just label Fn that side. So normal force, vertical component would be FA sine theta. So in this case, when we want to find the normal force, because of course Fk is equals to mu Kn, but the problem is we can't find Fk if we don't have the normal force, so we need to find the normal force. So in this case, the normal force is not equal to Fg perpendicular. Usually it is when it's an inclined plane, but the problem is we have an extra force there. So for them to be balanced, these two forces need to work together to be equal to this one. So in other words, Fn plus Fa sine theta is equals to Fg perpendicular. So how do we write Fg perpendicular? Fg perpendicular is mg cos theta. So let's substitute. So Fn is equals to plus our force applied, which is 500 newtons. So 500 times sine. So when we're resolving this, we don't use this component, we don't use this angle, we use that angle because that's what's really related to this force. So it's gonna be sine 10 is equals to mg, so our mass is 100 times 9.8 times cos theta. So whenever we use Fg and Fg parallel and Fg perpendicular, we always use this angle. So this angle is only for Fg parallel and Fg perpendicular, nothing else. So this is going to be cos 30, right? So of course, so that's what we're going to have. So let's take this to the other side. So our normal force will be equals to the answer of 100 cos 30. Okay, this is going to be 900. Cos 30 is root 3 over 2. So 980, 490. So the answer is going to be 490 root 3. Okay, you can verify that, but the calculator will give you this first, then decimals. And then sine, so that's going to be 250. So you just have to get the answer of this, and that will be equals to your Fn. And then that's what you'll substitute there. So our coefficient of friction is 0.1. And then the answer that we get for Fn is what we have to substitute here. Okay, so any questions, please comment below. You want me to make a certain video, comment below also. Don't forget to subscribe to my channel and please like the video.